All right, we're back. We're on page 60. We've been graphing inverse sine, inverse cosine. Now we're going to deal with inverse tangent. However, and I said in the last video that inverse tangent is like the hardest one to graph. That's not even remotely true. I graph inverse tangent like probably literally once a day when we're like actually in school. It's super easy to graph. It's really hard to graph accurately, but you don't need it graphed accurately like ever really. The only time what you need to know are the key features. So the key features, not key points, because there's two asymptotes that are features. You got 3 points, 2 asymptotes. So let's do this. This is going to be, this is our one-to-one tangent. So this is not the graph of arctan. This is just tangent where it's one-to-one. So what do we got going on here? Well, this must be pi over 2. This must be pi over. Remember, the period of tangent is pi. So for an you do pi divided by b, so the period is pi. Increment is pi divided by 4, the period divided by 4, so pi over 4. So that's why we are counting by these things. And then this will be negative pi over 4 and negative pi over 2. I put those up there so they're not like interfering, I guess. And then I know the tangent of pi over 4 is 1. And then, so since tangent is odd, if the tangent of pi over 4 is 1, the tangent of negative pi over 4 is the negative of the tangent of pi over 4. It's negative 1. So say things like that a lot, and it will help you a great deal. So if you look, you get 3 key points and then 2 key features. And so for these, I mean, they're already kind of there, but I'll dot them in. You get a vertical asymptote at pi over 2. I think I can just duplicate this and save a little bit of time. Duplicate. I wish you could see my lasso work on that. It's not great. It's like it's all over the place, but it works because you got to like avoid things that that I did not avoid, I guess. Let me eliminate some of this extra stuff. What are you? Get out of there. That wasn't supposed to be there. Okay. So there we go. We got 5 key features. We got to do the domain and the range. So the domain of our limited tangent is negative pi over 2 to pi over 2. And the range is all reals, and that's awesome. The key features, okay, so it's 2 asymptotes, 3 points. You can do them in order, or you can just do the 2 asymptotes and then 3 points, or, you know, whatever. Do whatever you want. But we got x equals negative pi over 2, vertical asymptote. We got negative pi over 4, negative 1. That's a point. 0, 0. That's a point. It's the best point to use. We have pi over 4, 1. And then we have an asymptote again at pi over 2. So 5 key features, not 5 key points. All the other ones have 5 key points. This has 5 key features because of the asymptotes. So what we're going to do, though, is we're going to take those and switch them around, right? So when we switch them, we're switching x and y, right? So the point negative pi over 4, negative 1 will become negative 1, negative pi over 4. We switch them. We switch x and y, which means x equals negative pi over 2 becomes y equals negative pi over 2. So that's what we're going to see when we go to this next step. Let's write down the domain. The domain should equal, or should correspond to the range of the limited, which was just all reals. The range of arctangent should correspond to the domain of the limited. So negative pi over 2 to pi over 2, not inclusive. That's a big deal. Key features, right? So the vertical asymptotes become horizontal. So y equals negative pi over 2. The inverse tangent of negative 1 will be negative pi over 4. The inverse tangent of 0 will be 0. The inverse tangent of 1 will be pi over 4. And then the x equals pi over 2 becomes y equals pi over 2. So again, 5 key features, unit circle figure. This I think is the most useful. So open circle, some sort of circular arc thing, you know, it's part of the unit circle. So that, I consider the unit circle figure to be the key to solving problems, to thinking them through when you get a little stuck or whatever. And then here's the graph of arctan, more or less. Well, no, this is like perfect, I guess. So we have a couple things here. So we have our horizontal asymptote at y equals pi over 2. We have a horizontal asymptote at y equals negative pi over 2. We have a point, switch colors. We have a point here. So this must be -1. This must be 1. This is why it's so hard to, by hand, get like an accurate graph. Here and here. Then just kind of go for it. So this is 1 comma pi over 4. This is 0, 0. That arrow is not even pointing right. And this is -1, negative pi over 4. So like so many things. 5 things, you got to know them. So if somebody asked me to graph this by hand, like on my own, honestly, I graph that and I like call it a day. If it's not like a quiz where someone's like, graph it and show all the key features, I just like go for that, because the thing that's most important are those asymptotes and also the inverse tangent of 0, 0. Like the fact that the graph goes through 0, 0 is like really helpful to remember. So that's what I'll do when I'm graphing it by hand. I don't do this nice computer generated thing. Obviously, I don't do the computer generated thing. Little review here. Let's see. Evaluate each of the following. Okay. So doing this from memory, because we memorized. Inverse tangent of negative √3/3. √3/3 is definitely a pi over 6 type situation. This is negative, so here's how I'm doing this. Right, so it can only come from there. It's negative, so it's from here, and it's a pi over 6. I don't know what I said. There's a lot of 3's in this problem. It's a pi over 6 type angle in the 4th quadrant, but it has to be negative pi over 6. Done. Pi over 4. So it's got to be from quadrant 2, and it's got to be as far away from the y-axis as you can get. That's 5 pi over 6, and then this is negative pi over 4. Similar argument to what I did for C, or you could just have them memorized. And then sketch each unit circle figure. Okay, so these are the best. So y equals sine inverse of x. I don't know why this is so small. Sine inverse is the right-hand side, and you count. Wow, it's raining like really hard. And the birds are going nuts. Y equals inverse cosine is the top half of the unit circle. Solid, solid, some sort of circular-ish thing. Y equals tan inverse. It's going to be the right-hand side, but you don't count the y-axis. So these are so useful, right? Like inverse sine of a negative, you know it's from quadrant 4, you know it's negative. Inverse cosine of a negative, you know it's from quadrant 2, you know that it's positive. It's somewhere between pi over 2 and pi. It's like the angle that you memorized for the unit circle. Inverse tangent, same as inverse sine, it's got to be 1 or 4. If it's 4, then it's going to be a negative angle. So you get a lot of information from those. I'm going to cut this video here, I think, because we're done with the page. I don't really want to go on. So I will see you in the next one for, I don't actually know what we're doing. Probably using these, I hope, because now we got all the graphs down, right? Memorize the graphs. You don't shift them. Just memorize them, the key features, 5 key points or 5 key features. And I will see you in the next one.